Everyone, welcome to the Chemistry Learning Channel. I'm very excited to share with you my passion of chemistry, and I hope you'll enjoy this video. In this video, I'll be discussing what is a mole and some concepts related to it and working on calculations together. So what is a mole? A mole is a unit that represents the number of particles. Each mole has 6.022 times 10 to the 23 atoms, which is Avogadro's number. It's similar to how we describe one carton of eggs as a dozen. It's a unit to represent. So if we say 1 mole, we mean there are 6.022 times 10 to the 23 atoms. If we say there's 1 mole of nickel, that means that there's 6.022 times 10 to the 23 atoms. And then if we say there's 1 mole of carbon dioxide, CO2 here, we mean that there's 6.022 times 10 to the 23 molecules, because this is a molecule. And then if we say 1 mole of KCl, we mean 6.022 times 10 to the 23 K plus ions and 6.022 times 10 to the 23 Cl minus ions. So what is molar mass? Molar mass is the mass of 1 mole of a substance, and it is expressed as grams per mole or abbreviated G per mole. It is found by summing all the substance's atomic masses, and in the future slides we'll be working a few examples. Another key formula we need to know is how to calculate the number of moles N given total grams of a substance and molar mass. So moles, which is represented with the letter N, is equal to mass, which is the lowercase m, divided by molar mass, which is the capital M here. And the units for this come out to be grams divided by grams per mole, and this shortens to moles, so we can verify that that is correct. In this slide, I'll be talking about how molar mass and atomic weight are related. So if we go to the periodic table, we find that carbon has a molecular weight of 12.01 grams. So this means that 1 mole of carbon atoms is equal to 12.01 grams. Similarly, the atomic weight of carbon can be represented as 12.01 grams per mole. So we flip the unit here. And then for 1 mole of oxygen, we similarly write 15.99 grams because that's the atomic weight from the periodic table. And then if we say what the atomic weight of oxygen is, we write that as 15.99 grams per mole. And then similarly with 1 mole of bromine atoms, we get 79.9 grams from the periodic table as its atomic weight, and that is represented as atomic weight of bromine is equal to 79.9 grams per 1 mole. So as you can see, we can see how these are very closely related. This problem, we will be working what is the sum of atomic weights of 1 mole of H2O. So first we'll start by gathering the atomic weights from the periodic table. And we get hydrogen has 1.008 grams, and then oxygen is 15.999 grams. Using this, we'll calculate the molar mass, which is also called the molecular weight. In order to calculate molar mass, we add the individual atomic weights of the elements. So H2O is 2 hydrogens and 1 oxygen. So we do 2 times the atomic weight of hydrogen plus 15.999 grams for oxygen. If we add this together, we get 18.08 grams per mole. In this slide, we'll be working what is the molecular weight of N2O4. First, we'll start by finding the atomic weights of the elements nitrogen and oxygen from the periodic table, and we get 14.01 grams for nitrogen, and then we get 15.99 grams for oxygen. Then, in order to find the molecular weight, similar to the previous slide, we see that this formula has 2 nitrogens, so we'll do 2 times N, and then 4 oxygens, so we'll do 4 times oxygen. If we do that, we'll just substitute the atomic weights. We get 2 times 14.01 plus 4 times 15.99 grams, which is equal to 92.01 grams per mole. In this problem, I will be working what is the number of moles in 20 grams of calcium carbonate with CaCO3. First, we'll start by listing the atomic weights from the periodic table, which is calcium has 40.078 grams, oxygen has 15.99 grams, and carbon has 12.01 grams. Next, we will calculate the molar mass. Calcium carbonate has 1 calcium and then 1 carbon and then 3 oxygens. So we will multiply the atomic weights by the number of each atom. So we have 40 plus 12.01 and then 3 times oxygen, which is 16. And then if we add these together, we get 100.09 grams per mole. And then we'll use the formula moles is equal to mass divided by molar mass to find the number of moles. So we are given that the mass is 20 grams, and then we just calculated the molar mass. So if we do 20 divided by 100.09, we get 0.199 moles because the grams will cancel out. Slide, we will be calculating what is the mass in grams of 0.6 moles of C4H10. Similarly, we will start by finding the atomic weights for hydrogen and carbon. We have hydrogen as 1.08008 grams and then carbon as 12.01 grams. Next, to calculate the molar mass, we see that we have 4 carbons and 10 hydrogens. So we will use the atomic weights and substitute. We get 4 times 12.01 plus 10 times 1.008, which is equal to 58.12 grams per mole. Using this, we will use the equation moles is equal to mass divided by molar mass. Then we will rearrange this since we are solving for mass. If we cross multiply and then set it equal to mass, we have mass is equal to moles times the molar mass. So we have the molar mass and we have the number of moles. When we multiply these two together, we have 34.87 grams. In this problem, we will be calculating how many atoms of copper are present in 35.4 grams of copper. This is a little different from the previous questions, and we'll be using Avogadro's number as well. First, we'll start off by listing the atomic weight. So for copper, it's 63.55 grams. And then we have the base equation, which is moles is equal to mass divided by molar mass. And then since we have the mass here in the problem, and we just calculated our molar mass, since it's just copper, it'll be the same. We have 35.4 grams divided by this atomic weight here, which is, in this case, since we have 1 mole, it'll be the same. So it's 63.55 grams per mole, which is equal to 0.56 moles. Using the number of moles, on the first slide, we learned that 6.022 10 times 10 to the 23 atoms is equal to 1 mole. And since we have 0.56 moles, if we multiply Avogadro's number by the number of moles, we get 3.37 times 10 to the 23 atoms. Thank you for watching this video. If you liked it, subscribe, like, and share.